So, Tuesday today, what if I asked you to find me an inverse function? So for instance, our first function is y equals 3x. My question to you is, what is the inverse of that function?
Y equals x divided by 3.
Okay, how did you come up with that?
I basically just flipped the x and the y around and then he solved it for y.
Okay, so step number one is you switch x and y. Step number two then is you solve for y. So our quote-unquote new y, because it's in a different spot. Okay? So first thing we do is when y equals 3x, that becomes x equals 3y, right? And then that becomes x divided by 3 equals y. And that's my new function. Okay? Find me the inverse. Whoa, what happened there? Find me the inverse of y equals x plus 7. What do I do first? What do I do first? Switch the x and the y. So that becomes x equals y plus 7. Then I solve for y. So what do I get when I solve for y? Okay. Let's kick it up a notch. Find me the inverse of y equals x squared. What do we got? First step. Switch the x and the y. How am I going to solve that one for y? Square root, right? So I get y equals plus or minus the square root of x. Because I'm solving, I got to put the plus or minus in there. Let's kick it up a notch. Y equals 3 to the x power. First step. First step. Switch the x and the y. So this becomes x equals 3 to the y power. And then I've got to, step number 2 is what? How am I going to solve that one for y? kind of an equation is it? Exponential. Okay? What's the inverse of exponentials? Or how do I solve exponential equations? Not roots. Roots would be like if in the one above it, when I've got a number up there. How do I solve exponential equations? Because the variable is now in the exponent spot. Yeah, can you? I use a logarithm. Yep, it's not a can, I do. Okay? So switching this into logarithmic form would solve it. Okay? Remember that we've got answer equals base to an exponent, switches over to my exponent because the logarithm is an exponent finder. So up here this would be y equals log of my base. So this would be log base 3 of what's the only part that I'm missing? The other side, right? My answer. So that would be x. Good times. Good times. Yeah. Let's kick it up another notch. Y equals the sine of x. First step, switch the variable, switch the x and the y. So this becomes x equals the sine of y. Now I got to solve for y, right? Well, if I take the inverse of sine, right? So then that would equal, because I'd have to do it in the same spot on both sides, right? Right? When you take the inverse of the function, what happens? No?
Doesn't it just cancel out?
Just cancels out. If I add 4 on a side of an equation, right? What's the inverse of add? Subtract, right? So if I add 4 and subtract 4 on the same side of the equation, what happens? Cancel each other out. Just goes away. A wash. Multiply by 4, divide by 4. Same thing. It's a wash. If I take the 4th power and I take it to the 4th root, that's a wash, right? Yeah, it was way up here. It made some distance. Okay, so 4th root, 4th power, those wash each other out. Okay, so this is going to end up being here y equals the inverse sine of x. Okay. Angle finders. Now, instead of output finders given an angle, now we're finding the angle given the output. Okay? We're switching the process. We're going in reverse. Okay? Let us graph the sine function. We've graphed it for many, many weeks now. Okay? Sine function does what Talk to me about a normal, regular old y equals the sine of x curve. The wave, if you will. Okay? Where does it go? What does it do? Where does it start? Starts in the middle. Then it goes up to 1, back down to the middle, down to -1, back to the middle, right? If I go the negative way, it would go down to -1, back to the middle, up to +1, back to the middle, right? So that this is -1, this is +1, right? Way out here, this is 2 pi. Half of that would be pi. Half of that would be pi over 2. The other half would be 3 pi over 2. Which means that this half would be negative pi over 2. This would be negative pi. This would be negative 3 pi over 2. And this would be negative 2 pi. Correct? Okay. I like it. Now, here's the cray-crayness. Talk to me first, before we get all cray-cray. What is the domain of sine of x? All real numbers. What is the range of sine of x? Yes? Okay. Now let's get cray-cray. Okay. I want to graph the inverse function. So I'm going to switch my x and my y. So basically I want to graph y equals the inverse sine of x. Right? Now, to make the function, what did we do? To make the inverse, what did we do? We first did what? Switched the x and the y, right? Then we solved for y. So first we switched the x and the y. So if I'm looking at my sine graph, what's the first thing that I'm going to do to make my inverse sine graph? What's the first thing I'm going to do? So I'm going to switch my x and my y axes, right? Yeah. Okay. So oops, I missed. Let me make my axes. That one, that one, that one, that one, that one, and that one. Nope, that one. So now, on the x-axis before was all of our pi's, right? And we went by pi over 2. So that's now going to be my y-axis. Because I switched my x and my y.
Wait, so do you actually label the top, the up and down the x now?
Nope. Nope. Still y. Okay. My y-axis before went from -1 to +1, right? So my x-axis now is going to go from -1 to +1. Because I switched axes. Okay? Now, let's look at individual type points. So if I look at this point right there, what is the coordinates on my regular graph? What is the coordinates of that purple point? This is the point negative 3 pi over 2, comma 1. So on my inverse graph, what is the point that I am going to put on it? 1 comma negative 3 pi over 2. Then, I'm not going to scroll up anymore. Okay? So then, at negative pi, where was my original function? It's at 0, right? So that means I'm going to be at 0, comma, negative pi. At negative pi over 2, I was at negative 1 before, correct? So that means I'm going to be at the point negative 1, comma, negative pi over 2. I started sine of x at the origin. So that's going to, the inverse will also go through the origin. At pi over 2, we were at positive 1. So that's going to be the point 1, comma, pi over 2. At pi, we went back to 0. So 0, comma, pi is going to be on there. A little too high. At negative 1, I will be at 3 pi over 2. So at 3 pi over 2 before, I was at negative 1. So I'll be at negative 1, comma, 3 pi over 2. So my graph, my inverse graph, looks like that. My question to you now is this. What is the domain here of my inverse? Negative 1 to 1, which is the switch of the range from before, right? Okay. What is the range now of my inverse? All real numbers. My question to you is this now. Is this a function? Is my inverse a function? Why not? Not the horizontal line test. Fails the vertical line test. Okay? So that's going to be an issue. It not being a function. Okay? We'll cycle back to that. So, notation for the inverse sine. There are two of them. Okay? The first one is y equals that one, which we've seen. We just graphed it. Okay? The other one means the exact same thing. Yeah, I should write it in lowercase because I've been writing all of my cosine or all of my trig functions in lowercase. The other one is called arcsine. Okay? Both of them mean the exact same thing. Okay? So you'll see it on the next slide both ways. Okay? So, because the inverse sign is not a function, I need to restrict my range, not my domain. I need to restrict my range. Okay? So, we are going to restrict the range to tell us where we're going to find our answers. So we're going to go negative pi over 2 to positive pi over 2.
Do you have to use that range, or could you have done a different one?
This one works for us the best. Okay? Because if I think about it, I hit all in that I hit all of the possible sign values there. Okay? If I would restrict it from 0 to pi, that wouldn't give me anything with negative sign. Okay? So that gives me both positives and negatives of all the values. Okay? So, on my graph here now of the inverse sign, there we go. So on my graph here now of the inverse sign, let's bring this down a little bit. So I am going from negative 1 out to positive 1. And I'm going from positive pi over 2 down to negative pi over 2. So my graph at negative pi over 2 of the inverse sign, I'm at negative 1. And at positive pi over 2, I'm at, make it look better, okay? I'm at positive 1. So that is where we are restricted. My domain is still negative 1 to positive 1. Right? Where am I on the unit circle? Where is negative pi over 2 to positive pi over 2 on the unit circle? Where am I? What? Nope. Nope. Where is positive pi over 2 on the unit circle? Where is positive pi over 2 on the unit circle? At the top. Okay? All right? At the top. Where's negative pi over 2? At the bottom. Okay? So am I on the left half or am I on the right half? Can't be on both. I got to be on one or the other. Where is this range of values on the unit circle? The right half of the unit circle. So inverse sign is found on the right half of the unit circle.
Can you explain that? Like, how did you know that?
Where are angle measures that are from pi over 2 to negative pi over 2? So here's 0, right? On the right, out to the right. This gives me all positive angle measures up to pi over 2. This would give me the negative down to negative pi over 2. Okay?
But then why wasn't it like, because like in your range, this cosine was.
I'm not dealing with cosine. I'm dealing with sine right now. Okay? So I'm looking at the y parts. Okay? All right, let's put it to work here now. So again, we are restricted to the right half of the unit circle. That's it. Okay? So I'm talking about sine. So that means I'm looking at x or y. Looking at y. And remember, right half. Okay? So get out your unit circles because you're going to need them. Arc sine of 1/2. Okay? Where on the unit circle is sine equal to 1/2? Pi over 6 and 5 pi over 6, right? So if this were just what's the sine at pi over 6 or what's the sine at 5 pi over 6, in both of those questions you would give me 1/2, right? Okay. Which one of those two is on the right half of the circle? Pi over 6. So my answer here is just pi over 6. Because 5 pi over 6 is on the left half of the circle. Where is the inverse sine equal to negative 1/2? 11 pi over 6? Do we agree with 11 pi over 6? My only other option would be 7 pi over 6, right? But 7 pi over 6 is on the left half. I'm restricted to the right half of the circle, right? But does 11 pi over 6 fall in my range of negative pi over 2 to positive pi over 2? So I can't give 11 pi over 6 as the answer. What can I give in its place? Negative pi over 6. I'm on the right half, and I'm in that range. Okay, I gotta be in that negative pi over 2 to positive pi over 2 range. 11 pi over 6, yes, that's the angle, but it's not in that range. Gotta be negative pi over 6. They mean the exact same thing. One's right, one's wrong. Okay? Even though you're talking about the exact same thing. Okay? Find me those 4. Plenty of time. Inverse sine of square root of 3 over 2. Pi over 3. In my range, right half of the circle, pi over 3. Arc sine of 2. Where on the unit circle is sine equal to 2? On the right half. Pi over 2, it's equal to 1. I want it to be equal to 2. It's a trick question. What's the biggest of the sine values can be? 1. What's the smallest the sine values can be? -1. Does that fit in my domain? No, not possible. Not in my domain. Arc sine of 0. 0. Inverse sine of -1. Negative pi over 2. Not 3 pi over 2, negative pi over 2. Okay? Have yourselves a great day.